Well, good morning, everybody. Today we are learning 3-3, Day 2, Key Features of Functions. In this lesson, we're going to review how to write domain range and something that we have previously learned, such as x-intercept, y-intercept, as well as new stuff such as something called extrema, like what is an extrema of a function. So in this lesson, it's mostly we're mostly going to identify something from a graph. There's not much calculations, there's not a lot of fractions, not a lot of decimals. It's something that can you identify something out of the graph. If I give you a graph, can you name me some key features? Can you name me some parts of the graph using some vocab words, things like that, okay? So before we start the lesson, let's do some review, something that you have to know before this lesson. Previously, we learned that domain and range, we're going to write in the interval notations. And for domain and range, we have to look at the graph, right? Some parts of the graph. So let's say you have this graph right here, named f of x. To find a domain of this graph, we first look at how left and how right this graph extends. Now, if you look at this graph, the left side looks like it's going to infinitely all the way to the left, especially indicated by this arrow. This arrow means that this graph is going to the left forever and ever. So left-wise is going all the way to negative infinity, and then right-wise, I know that this graph is going down, but it's still approaching slightly to the right as it goes down. So left-wise is going to negative infinity, and then right-wise is also going to positive infinity. So for domain, it's going to put open parentheses, negative infinity, comma, infinity, close parentheses. And remember, for infinity, we always use the parentheses. We never use bracket because we will never reach or can include infinity. Infinity is not a number, it's just a relative symbol that tells us that, hey, we're going on the number line forever and ever, okay? And for range, same thing. Instead of looking left and right, we're gonna look at up and down of a function. So it looks like for this function, it went all the way up to the highest number of 3. There's not really anything more than 3. So the highest number, the highest that this graph goes is going to be positive 3. What about the lowest? I see that there's an arrow going down forever and ever. So going downwise, this function goes down to negative infinity. So to write it, we're going to go from bottom to top. So the lowest number that is going to go is going to be negative infinity. The highest number that this graph is going to go is going to be positive 3. And since at 3, the dot is a closed dot, we're including 3, so we're going to use a bracket. So for your range, it's going to be open parentheses, negative infinity, comma 3, close bracket. Okay, and then for the x-intercept, you're going to just write the ordered pair. X-intercept is just the intersection between the graph and the x-axis. So in this case, it's this dot right here. This dot is the x-intercept. And to write this dot, we're going to write it in the ordered pair. I know that the x value of this dot is 4, and the y value of this dot is 0. So we're going to write 4, 0 in parentheses. So I don't want you to get confused between interval notations and order pair. Order pair, we always use parentheses to indicate the location of a point. And in interval notation, we use brackets and parentheses to indicate a range of values, right? Like the least values, the greatest values, things like that. So likewise, for y-intercept, we're going to find the intersection between the graph and then the y-intercept, which is this point right here. So for this point, the y value of this point is 3, and the x value of this point is 0. So we're going to write 0, 3. And like I said it before, the main goal of this lesson is to review how do you identify certain parts of a graph, such as domain, range, x-intercepts, and y-intercepts. Let's move on to the actual lesson, 3-3. In 3-3 key features of functions day 2, we're going to incorporate x-intercept, y-intercept, as well as something called extrema. What is an extrema of a function? Think of extrema as like the highest point and the lowest point of a graph. It's like the top of the hill or the bottom of the valley. And those are the extrema of a function. And there's two types of extrema. One of them is called the maximum. Maximum is going to be the top of the hill, the highest point, right? So we're going to say the highest point. And then the other one is the opposite, which is the minimum. And that is the lowest part of a graph. So it is maximum or minimum. So that's the two types of extrema. Here's some examples for you. Look at this V shapes here, this absolute value functions. I see that certain points are y-intercept. So in this absolute value function, there's one y-intercept and there's two x-intercept because it crosses the x-axis twice. And at the bottom of the absolute value function, this is the lowest point, and we call that the minimum because it's at the lowest part of the graph. And on the next one, we have the parent function is the quadratic because it's like a little U shape upside down. And in this case, we see that it crosses the y-axis 1, so this is the y-intercept. And here it crosses the x-axis 1, so it's the x-intercept. But at the same time, this is the highest part of the upside down U shape. So this is at the same time a maximum of a graph because it's the highest point, it's like the top of the hill. So this is both x-intercept and maximum of the graph. The last example, this is a linear function, right? The name of the parent function is linear functions. I see that this linear function, it crosses the x-axis and y-axis at 0, right? And so therefore, this dot is both considered both x-intercept and y-intercept. And this line does not have the highest point or the lowest point because it does not have any, there's no top of the hill or the bottom of the valley. It just continues going up, has a positive slope. So therefore, there's no maximum or minimum in this graph. Well, once you have learned what the x-intercept, domain, range, maximum, minimum, things like that, we're going to put all of them together in one problem. So I would like you to take a look at this problem, this graph right here. This graph looks like the parent function is an absolute value function with like 6 ordered pairs. So step 1 is I want you to write out all the ordered pairs of these 6 points. So I see that, let's do from left to right. We're going to go from smallest x to the highest x. So here the order pair is -4, 2. We're going to write it here. -4, 2. Then the next order pair is -2, 1. Okay. And then this order pair is easy, is 0, 0. This order pair is 2, -1. This order pair is 4, 0. And then lastly, this order pair is 6, 1. And as we have discussed, the name of this parent function, because it's a V shape, it is the absolute value function. We're going to write the entire thing down. And for domain, I see that, well, let's check how left and how right this graph goes. Well, left-wise, this graph goes all the way to the left with this arrow pointing to the left, so it's going to be -infinity. Likewise, this graph is going to the right forever with this arrow pointing to the right. So it's going to the left all the way, it's going to the right all the way. So for your domain, the smallest number for the x value is -infinity, and the highest value is going to be +infinity. And you're going to use parentheses to indicate infinity always. Then for the range, you look at the top and bottom. How low did this V shape go? It looks like it goes all the way down to -1 on the y-axis. Now, how high does this V shape go up? Well, since it's going forever, it's going to go up forever as well. So the lowest point, it's going to be at -1. So we're going to use bracket -1, comma, all the way up, which is +infinity, close parentheses. Well, in this graph, we also have some x-intercept. In this case, we have 2 x-intercept here. One is right here and one is right here. So for this order pair is 0, 0. And for the other order pair, it's going to be 4, 0 because it intersects the x-axis at the value 4. Now for the y-intercept, I see that it crosses the y-axis here, which at the same time is also your x-intercept. So this is a special dot. Whenever you have a dot at the origin, it is both considered x-intercept and y-intercept. So in this case, your y-intercept is also 0, 0. Well, does this graph have a maximum, a minimum, or none, or neither in this case? Well, let's take a look at this V shape. I see that this V shape, it looks like a bottom of the valley. So this part will be considered a minimum. So we're going to write the words minimum. And the order pair of this minimum is going to be 2, -1. So we're going to write it here, 2, -1. Okay. And then something new is, what is the value of the extrema? The value of the extrema is how high or how low is the extrema. So to find how high or how low, we always use the y value, because the y-axis, it always goes up and down in a coordinate plane. So in this case, since you have the order pair 2, -1, the value of the extrema is always your y value of the order pair. So in this case, we're just going to say -1, and then that's it. We're going to take a look at more parent functions. So in this case, we have this U shape here. Let's fill out some order pair first, again from left to right. So on this dot, it's going to be 0, 4. So for part A, for the first order pair, we put 0, 4. Then moving on to the right, we see this order pair having the coordinates 1, 1. So we're going to put 1, 1. Then moving to the right, this order pair, it's going to be 2, 0. Then moving to the right, this order pair is going to be 3, 1. And then lastly, this order pair is going to be 4, 4. We're going to put it right here. Well, the name of the parent function is quadratic because it looks like a U shape. So it's a quadratic functions. Now, domain will be very similar. If you look at this U shape, it's going to the left all the way with an arrow pointing all the way to the left. And the same thing, to the right, this arrow is telling you that this U shape, it's continue all the way to the right. So for your domain, it's -infinity, infinity with parentheses on both ends. And then for the range, I see that the bottom of the U shape, it's at 0. It's at the ground level. So it's going to be including 0, so 0 bracket. And then the U shape extends all the way up to infinity. So we're going to use positive infinity to indicate the highest point with a parentheses at the end after the infinity sign. Well, for the x-intercept, I see that this U shape intersects the x-axis at this one point only, and this point is at 2. The value is 2, so it's going to be 2, 0. And then for the y-axis, I see that this U shape intersects the y-axis at this number, which is 4. So it's going to be, the x is 0, the y value is 4. Well, does this graph have a maximum, minimum, or neither? So that looks like the bottom of the valley, right, like a U shape. So this part is going to be the minimum. And what is the order pair of the minimum? Well, which is same as your x-intercept right here. It's going to be 2, 0. Well, how low is this, the bottom of the valley, the U shape? Well, it looks like it's on the ground level. So again, it's the y value of the order pair that you just wrote, which is just 0. And then that's it for this example 2 of quadratic function. Well, lastly, you have another function. In this case, it's a straight line. So it is easy for us to write the order pair. So first, let's start from left to right. So in this case, it's going to be this dot, the order pair is going to be -4, 2. We're going to put -4, 2 as your first order pair in the table. Then after that, let's move a little bit to the right. So this order pair is going to be -2, +1. So we're going to put it right here. Well, this order pair is easy because it's at the origin, so it's going to be 0, 0. Then moving on to the right, this order pair is going to be x is 2, the y is -1, so it's going to be 2, -1. And then lastly, the order pair of this dot is going to be 4 and -2. 4 and -2 like this. Well, since this is a straight line, the name of the parent function, it's a linear function, which you have been learning it since middle school. Then the domain looks like this line is extending to the left all the way and extending to the right all the way with arrows on both ends. So it's going to be -infinity to +infinity. Likewise, for range, looks like it's going all the way down with this arrow and looks like it's going all the way up with this arrow. So for your range, it's going to be the same thing from -infinity to infinity. So it's extending all the way in different directions for linear graph. So linear graph is always having domain and range -infinity to infinity as long as it's not vertical or horizontal. As long as you have a line that is slanted, your domain and range is going to be all the way, extend all the way in all directions. Okay? Well, for your x-intercept, looks like this graph intersects the x-axis at 0, so it's going to be 0, 0. Well, since this is at the origin, your y-intercept is going to be the same thing. It crosses the y-axis at 0, so it's going to be 0, 0 as well. Well, does this straight line has a maximum, minimum, or neither? Well, there's no top, there's no bottom, there's no highest or lowest point. So in this case, it's going to be neither. It has no highest or lowest point. Well, if you do not have a maximum or minimum, there's no way for you to write the order pair. So you're just going to write none. There's no extrema. And there's no value of extrema as well. So you're going to write none. And then that's how you identify some key features of a linear function. Well, your homework for this lesson will be very similar. The order of the questions from A to I is pretty much exactly the same as in the lesson. And I will give you some guidance if you need help. Otherwise, if you have any questions, please let me know. Thank you so much.